Hello everyone and welcome to the second or last part of this field determination of transmissibility and storage coefficient. So, in the previous discussion we have discussed various conditions and how we can achieve a steady state or in what conditions we do not achieve steady state and so on. Now, in order to avoid a lengthy discussion or video, I have segmented in two parts, and this part is going to be little less as compared to the previous one. But in order to keep things in proper perspective, two parts had to be created. Anyway, so now we will be discussing about aquifer test. So, this common aquifer, what are the common aquifer tests which are performed is a hydrological or hydrologic situations for which analytical methods have been devised. And second is the collection of field data for various common methods. Field data is very important, and field data includes geological informations as well as water levels as much as possible from surrounding wells, whichever the open wells are there or tube wells or from whatever the methods by which we can get the water level in various wells. This is very important towards the aquifer test. So, which are the most common hydraulic situations are, the first one is the, of course, generally we are having vertical well, and we would like to achieve a constant discharge. That is our aim. Initially also in the first part of this discussion we have discussed this part that we would like to withdraw the water perennially with the same amount of water all the time. So, we want constant discharge, but whether there is a recharge is also there, that we have to think without any vertical leakage. That is another important thing. In there are conditions or leaky aquifer conditions or some other geologic conditions may be there which will have the vertical leakage. So, what we are looking a well constant discharge without any vertical leakage. Further, in this another situation where we are looking vertical well constant discharge with vertical leakage. So, here in the second option we are having with vertical leakage, and the third one is the vertical well constant head without vertical leakage. So, here we are considering here constant head without vertical leakage. So, what basically our meaning is the constant head is that the well is either pumped or recharged at a continuously varying rate, and the drawdown or built up in head remains constant during the test. So, this is where we say constant head, or you can also call as water level, constant water level in that and little loose sense. Now, in all these three so far the situations, what we are seeing common is vertical well. In groundwater engineering, we mostly talk about vertical wells. So, we have to specify here because there are other types of wells which are used in other type of investigations or explorations. So, we had to specify here that vertical wells because we would like to withdraw water, and that is the most convenient way to understand our aquifer conditions. The fourth one is the vertical well, and instead of constant head now we are having variable discharge and variable head without vertical leakage. And then of course, the fifth one would be the vertical well instantaneous discharge or recharge. So, all these situations might be there in most common hydrologic situations are there, but in all cases you have seen that vertical well is common because this is what we consider in groundwater engineering. Now, the sixth possibility is there horizontal well. Again, as I have already said that horizontal wells are rarely used in groundwater, but maybe sometimes because of interconnection of wells or some other special geologic conditions in which we may go inclined wells or horizontal wells instead of vertical wells. So, in this horizontal well, they may be either a groundwater drain or surface channel at which the aquifer discharges. So, like when two water storage or two small reservoirs are to be connected, then there are two possibilities. One we can connect through the surface channel, another one we can connect through a horizontal well or a drain which is in subsurface condition. So, that well we are calling here as horizontal well, and in which the situation would be that constant discharge without leakage, because when vertical well will be there, that well might be going in the one single formation, and it may be, if beds are not horizontal, layered beds are not there, then within a one horizon or one type of bed, the entire horizontal well may be there. So, we can achieve a without leakage situation also, with constant discharge also. So, because the conditions might not be changing if the situation is that you are having a same lithology throughout that horizontal well. A seventh situation can be that we are having horizontal well, constant head without leakage. So, here instead of constant discharge, now we are having constant head and other conditions remain same. The eighth possibility is the horizontal well, constant head and uniform leakage. So, most ideal situation in case of horizontal well, that there we would like to have a constant head, nothing change there, and we get the uniform leakage throughout the well. So, in the above these 8 possibilities or 8 situations, in aquifer test situations, constant discharge from a vertical well is the test which is most commonly used. In earlier discussions also we have said that we would like to first withdraw water and would like to achieve the constant discharge. That means the steady state conditions, and then all these tests will start. All these observations and other things. So, observations will be done from initial stage onward, but when we achieve this steady state condition, then real data will be analyzed to achieve or to know about hydraulic characteristics of aquifer and a pumping well. So, lot of information or list of information commonly collected either before, during or after a test in order to analyze the data. What are those information which are commonly collected? First, about the construction features of a well, whether like what is the diameter, what is the total depth of the well, or depth or at which well is open, because in hard rock terrains casing may not be there throughout, or casing may not be there at all, but in soft alluvial kind of conditions or in soft rock conditions, we may be having casing from the top part, and in the bottom we may allow some openings through certain different design of pipes or different designs of even opening. So, we would like to know every such information will come under this large heading, which is the construction features of a well. That is, what is the diameter, which is very important, what is the depth. Generally, when you ask somebody in a common situation, they will immediately tell the depth, but they may not be knowing till what depth the casing is there and then it is open or slits are there. So that because when the well is designed, after these tests it is found that aquifer at a certain depth. So, only in the at that depth there are slits or entry points or opening in the pipes. Otherwise, the rest of the from top to till aquifer, the pipe may not have any openings, and whether it is finished with a gravel pack at the bottom. So, that is also from the top as well as bottom, all these informations are required, which will come under the construction of well. The second and other common and important information which is required before all kinds of these aquifer tests is the geological features or geologic conditions of the formations in which the well has been constructed. So, that means the character and thickness of the aquifer, means geologic nature of the rocks, overlaying and underlaying rocks, that we may be having a confining aquifer condition. So, what are the impervious rocks and what are the overlaying rocks and aquifer rocks, and then of course, the position and nature of hydraulic boundaries in the surroundings, that these all will come under this geological features of aquifers. So, these common informations, we have a large two common information we have discussed. Now, the third one, now we are at regional water level. In the beginning also I have said in this discussion that it is always to know what are the water levels in the surrounding wells. So, regional water level is required, and the trend prior to the test. What is the trend? Up and down trend of water levels in the aquifer and the rate of rise or decline. You know, like in Indian conditions, that this up and down of trend of water levels, pre-monsoon and post-monsoon, these at least two water levels are very much required. If we do not have the continuous monitoring of wells, of observation wells or data, then at least these two information, pre-monsoon, what was the pre-monsoon water level in a well and what was the post-monsoon water level, that will give us a lot of idea about the aquifer conditions of the well. And then pumping rate during test. What was the pumping rate? What was the start time of discharge? And the pumping rate must be constant from the instant withdrawal start. We may not achieve initially, but this is what the target is. This is what the objective is, that we should get this constant pump discharge rate. And also the amount of decline or water level resulting from pumping, and that is the time of observation. Once the pumping has started, how this water level in the well is affecting, whether it remain constant or going down, or sometimes if it reaches to a level on the outer boundary of cone of depression, if reaches to a recharge situation, then the discharge may increase also, but it depends on geological conditions and aquifer boundaries also. So, after these 5 situations or 5 commonly collected informations, now we require the time of each water level observation is thereafter noted in case of aquifer test with respect to the number of minutes, seconds since withdrawal started. So, there will be a complete time log of water level situations, and not only water level in that well, but also surroundings. At the same time, these water levels are noted. So, maximum interval between observation is generally about 1/10 of the time elapsed since pumping started. So, for example, depending on the stations or time, see the elapsed time. Initially the pumping started at 0 minutes, then 1 to 10 minutes, 30 seconds, the interval between measurements, 10 to 20, 1 minute, and goes on, and 300 to 400 minutes, and then this interval between measurements can be 30 minutes, because at this stage once the elapsed time has become larger, at this stage the measurements can be done in a sort of I would say in a longer time, rather than at the first to 10 minutes stage where only 30 seconds are done. Now, here the field data plot. Now, we will be doing plotting the field data, that means the drawdown versus time minutes on logarithmic paper. Recall these methods and the graph which we have discussed about the semi-logarithmic graph we have discussed, in which we put the time versus drawdown and would like to see how things are behaving, that means how water level or whether we are achieving this steady state or not. So, that we keep doing plotting during the pumping test or aquifer test the field data on the semi-logarithmic scale, as we have discussed while discussing Jacob methods or Theiss methods and graphs or these plots, or sometimes you may find people are using word curve, and these curves we keep plotting. Basically this is a semi logarithmic paper, x axis we are having, on y axis with that time you or drawdown and versus time you keep plotting on semi logarithmic paper. So, what these plots will show, as we have already understood in our earlier discussions, that how things are progressing and whether we are going to achieve that steady state or non-steady state or whatever. So, if suddenly there are anomalous changes, suddenly there is a change in the water level which is occurring level as planned till the end of the test should be continue until the cause of change can be established. Because in subsurface conditions, it is not possible all the time that whatever we are predicting, this is how a well will behave. So, suddenly there might be change in the water level from start and then near end. So, that kind, but we should not stop pumping test, we should continue. And the 7th point here, very important one, is the recovery of water level. So, once for longer time water has been withdrawn from a aquifer, then you allow the recovery of water levels to achieve. And in earlier discussions also I have said, even in normal practice the water is withdrawn till say evening and then overnight it is left, and that is the phase which is the recovery of water levels or reducing the cone of depression or completely removing cone of depression, depends on aquifers. In confined aquifer conditions, this recovery can be very fast. In unconfined aquifer conditions, this may be different. So, recovery of water levels, again the values are noted, because that will help us to understand the entire behavior of an aquifer. So, when we stop pumping and we allow water levels to achieve or go to the original initial stage, then if pumping rate was irregular, and this recovery of water level or measurements are done when we are encountering anomalous changes in our water level during our pumping. So, we will keep noting the water levels with the time, that means the drawdown time curve, so that this irregular beginning of the test or if natural trend of water levels changed during the test. So, this will help us to understand whatever the behavior of an aquifer. So, generally what in practice people note all this during the pumping and after the pumping, so that we will understand completely the aquifer characteristics where the well is there. Now, the recovery of water levels, that only we need to observe if the pumping was irregular in the beginning of test. However, few hours of recovery measurements are generally useful. So, this sometimes it is not necessary if there were no anomalous changes in water level or discharge, then it may not be required to monitor for longer time about the recovery of water levels. But at least initially for few hours, these measurements of recovery are generally useful, as I have already mentioned. Generally it is done initially, maybe for few hours, but may not be for days together, depending on aquifer condition, confined and confined. These are two completely different conditions. So, for this purpose of confining the early drawdown measurements, this will help us to understand the initial drawdown curves also, or cone of depression. And finally, we come in this discussion as with the drawdown measurements, the time of each observation is accurately determined with respect to time of pumping cutoff. So, when we are doing pumping, things are being accurately noted down in our field diary, and plot is also being made at the same time. Similarly, when the pumping is stopped, again the same exercise is being done. You can say in a sort of reverse way that time T0, as soon as you have stopped the pumping, that T0, and then later on time is added, and for a few hours such kind of measurements are done. This all this information will allow us to understand many things about the aquifer and our well test, pumping test. So, this will allow us to understand whether we are having a confined aquifer conditions, unconfined aquifer conditions, whether we are having some boundaries. The boundaries may be recharge boundary, aquifer boundaries may be a discharge boundary. When we are going to achieve a steady state and a steady state, when we are going to achieve non-steady state and so on. All these observations will allow us, and plotting of data, drawdown versus time, will allow us to understand almost completely, I would say almost, not fully, the aquifer from which the water will be withdrawn for long time. So, with this I end this discussion. Thank you very much.